When Steve Carell asked Elizabeth Banks, "Do you like to do it yourself?" I thought to myself, well, of course I do, because building something from scratch is totally awesome. Whether it's a simple piece of electronics to put on display at your desk, or if it's a purpose-built device to improve your life, DIY projects are the bee's knees. In the last few years, the resources and outlets for sharing ideas has exploded. It's thanks to the maker movement, and RadioShack proudly plays a role. New life has been breathed into the drawers full of fuses, diodes, and other components thanks to the excitement and ingenuity of DIY enthusiasts. For years, those drawers are exactly what RadioShack customers thought of, and now with the maker movement on the rise, we're excited to have everything you need for your project. But what if you're just getting started as a maker? Where do you begin? Don't worry, we've got you covered. Not only do we have the electronics, but we also have guides to help you on your way. We have books on basic electronics, programming, and robotics. That's right, I said robotics. You'll be cranking out androids faster than you can say Noon Yin soon. These guides help establish the fundamental knowledge needed to make your own electronics or repair existing devices. Between that and the pieces in the parts drawer, you're halfway there. We've also got toolkits that have the must-have gadgets that will be found on any maker's workbench. And if you want to make some electronics work, we've also got soldering irons to get everything connected. One question though, what is to solder?
Soldering and you! This is a soldering iron. It's used to connect components together with solder. This is solder. Once your soldering iron is turned on, have a look at the temperature. 700 degrees Fahrenheit. There's one thing that our human bodies have in common with that of a scientist. 700 degrees does not get along with flesh. For science sake, don't touch anything on the business end of the iron. Please put it back in the holster when you're not using it. Also, be sure not to have any materials or chemicals around that react spontaneously to heat. Toasty. Let's begin by laying out all of the components. Holding the board confidently, put the button in place with the prong sticking through the back of the board. With the iron and solder in hand, heat the pin sticking out the back by touching the iron to it. Then you touch the solder to the pin. You may need to graze the solder to the point of the iron just to get it started. Well done, scienceman. Like the button, insert the battery clip with the prongs through the board. Use the same technique to solder it in place. Science. Now, insert the LED. The long lead is the positive and the short is the negative. Bend the LED into place. The Stanislavski bend. Separate the leads to make soldering even easier. Solder it like it's hot, which it is. Now, let's see if your soldering is worth anything. Insert the battery into the clip and test the light. By George, it worked! Good on you! Take the rest of the afternoon off. Soldering and you!
The soldering iron that we saw the scientist use was pretty fancy. You don't have to get anything that big when you're just starting out. I recommend using a basic pencil iron. They're easy to use and they're easy on the pocketbook. They all vary basically by wattage. Wattage determines the temperature of your soldering iron, and that matters because different projects may require different kinds of solder. What do we know so far? RadioShack has great resources about making. We've got all the parts and pieces needed for a project, and we know how to solder. So let's talk to an actual maker to learn more about DIY. I'm here with Manny Alviar. He's one of our technical writers here at RadioShack, but more importantly, he himself is a maker. How you doing, Manny?
I'm doing great. How are you?
I'm pretty good. Let me ask you, so how did you get your start in making and doing DIY projects?
Well, it actually started from working here at RadioShack. As a technical writer, I get to see all of our products that we put out, and I always have to get my hands dirty with them and play with them. And as I started working with more of our DIY line, I started learning how to use it, and it got really exciting.
So for anyone who wants to kind of cut their teeth in becoming a maker, there's got to be a starting point.
One of the things that I think is a great starting point is our Learn Electronics kit. It comes with a book that includes projects, and in fact, I started using this with my kids as well. You learn what the different components do, what resistors do, capacitors, how to wire LEDs and complete circuits. And it doesn't really involve any soldering because all the wires are spring-loaded here. So it's a really cool way to kind of make circuits, modify circuits, see how they change over time, and really learn what each individual part does.
We've got our learning electronics kit, and that gets us a pretty good foundation of understanding. Where do we go from there?
Once we've worked with the kit for a while and learned what the individual components do, the resistors, the LEDs, kind of understanding how they work, it's good to move to the microcontroller pack here, because what this does is it gives you a chance to actually learn how to make it smart. You've learned what they do, and now how can you automate it, kind of set it up to do something that you can walk away from and just kind of see it run for a while. So this gives us a chance to automate it, and you can do anything from LEDs to sounds to a lot of different experiments. I also like this because it includes a breadboard, so that you're not soldering necessarily with this kit right away. So you can actually set up different circuits, try different things out. There's a lot of different experiments you can try. Because it works with an Arduino, it's open source, which means that there's a lot of resources available online that you can go to. People put their own code online, make it available for anybody to use, and you can learn how to do it that way.
So the Arduino kit that comes with this is pretty much the introductory Arduino, right?
Yes.
What you learn doing this, can you apply it as you kind of grow as a maker?
Yeah, the Arduino Uno is a great board. It's a good starting point. The program that you learn with it is very simple, it's very intuitive, and it translates well to the more advanced boards. So as you do more and more projects, more complex projects, you're really doing the same type of coding.
I mean, it seems like it can be said about making in general that you know, as you learn new things, that you just kind of build upon the fundamentals, and everything that you learn is going to be put to use, and you kind of grow as a builder, grow as a maker. You know, that's just really cool. So from there, where do we progress? This little guy.
Well, we started, learning just kind of what the circuitry does, what we can do with the parts. And we start to learn how to program it, how to make it do some really cool things. From that point, we really want to be able to do something that really stands out, it's really cool, and it's also something that we can build and actually kind of stand alone, which is where we go to something really cool like the 3D LED Cube Kit. I've made several of these, and I made these with my kids. They're a lot of fun. And what this is you actually start to incorporate tools as well. You're using a soldering iron to assemble it. It attaches to an Arduino so that it's programmable. And you can make the cube light up in various patterns, which is typical for this type of project. And when people see it, that's where you kind of get that wow moment.
So a maker comes in and is learning and getting these fundamentals down and working their way through kits. But I'm sure one day they're going to get bit by the bug where they want to build something from scratch. How do you even begin to make a decision as to how you're going to do that, what your approach is going to be?
There's so many kinds of projects that you could do, and for each of those, there's a lot of people who have already gone through that experience, and they form there's a lot of communities out there, including our own, which is dit.radioshack.com, where we have a lot of makers who are interested in different areas, such as robotics or music, and that they provide their own projects, all open source, so they provide, the instructions for it, the parts that are necessary for it, the code that we could go into the Arduino to make it run, just all kinds of areas out there. So really, if there's anything that you want to build, you can start with those people to kind of give you some inspiration, some ideas, and you can take those ideas and actually take ownership and make them your own by building on them, combining them, or doing something, completely departing from that.
Manny, thank you so much, man, for walking us through the process of, getting started as a maker and how to progress and learn more about the kits and to move on and build that knowledge base. It's really awesome, man. Do you have any, words of advice for, someone who's getting started?
Sure. I'd say the one thing that you really want to do is take advantage of the community around you. There's a lot of people who are out there who are eager to help you.
That's right. I mean, because there's no I in DIY.
So, what are you building?
I'm not really sure yet. A buddy of mine at work is really into this stuff, and I just don't know where to begin.
Okay, cool. Well, since you're just starting out, I recommend getting a basic electronics guide. It'll give you a really good idea of what parts you would need, how things work, and how to do things safely.
Oh, I didn't realize you had how-to books.
Gotta get started somewhere. And speaking of that, why don't you have a look at these? Here are some basic kits to get you familiar with circuits, and you could even get some soldering practice in.
So, what kind of soldering iron would you recommend for a beginner?
I would recommend a basic pencil iron.
Are they hard to use?
No, if you can hold a pencil, then you could use this. You just have to remember that the tip gets hot, like really hot, 600 to 700 degrees hot. So as long as you have a steady hand, you're really careful, you'll have a lot of fun and avoid the need for aloe.
So, as I learn more, do you have harder kits, or do I just start building things on my own?
Why not do both? We've got some more challenging kits that play with robotics, programming, and more, but if you find yourself in a pickle that you think you can work your way out of with a little bit of ingenuity and elbow grease, go for it. We've got everything you would need right here.
This seems really cool. The guy I work with really sold me on this stuff, and I'm just glad there's a starting point for me.
Absolutely. RadioShack has its own website that you can go to called dit.radioshack.com. It's got real projects on there built by real people just like you, and you could even go on and add some yourself.
Oh wow, I didn't realize so many people were into this stuff.
Oh, buddy, you're joining a huge world of inventors, thinkers, and builders. I just know you're gonna love it.
That's it. DIY in a nutshell. I hope you see what interests makers and what makes them tick. To know that everything that they need is right here in the store inspires a little courage about the old parts drawers. If you've got an extra couple of minutes, check out the link just below this video to see our experience at the 2014 Bay Area Maker Faire. It'll give you a glimpse as to how big this maker movement really is. For more information on DIY products, check out the June 12th Huddle Guide, our intranet site, and the DIY section on RS Connect. And if you're a maker yourself, why not share your projects out there too? Thanks for checking out the goods.